So, as I said, my name is William Weatherland. I've been with Global MRB for 15 years. We've worked with engine emissions quantification, research and development, and overall vehicle performance for and health for about 25 years. And that includes all types of transportation from trains and trucks, which we'll discuss some today, but also Global MRV also works with passenger cars, high performance sports cars, ocean going vessels, off road construction, recreational vehicles, and the list goes on and on. Now, this webinar today, we're going to go for about 30 minutes, and with a Q&A to follow, I'll open it up. But anytime you got a question, please, put it in the chat. I'll try to monitor that as much as I can to make sure that I'm keeping up with everything. Just bear with me for a second. All right. I'm hoping to be doing these conversations about once a month on emissions related subjects, and that's emissions related subjects throughout the globe, from vehicle development and research to electric production to testing and validation. Really, I'm curious as what everybody out there that attends these things would want to talk about, would want to discuss. So during the webinar, if one of these sidelines interests you, please, let me know, and we'll, hopefully discuss it in the future. Now, today, we're talking specifically about which is more emissions efficient, trains or trucks. I think if you participated in emissions in the past, you already have a idea of what you feel like that answer would be. But the question that I want to put out to you today is, which is how much efficiency do we find a difference in this? Are trains vastly more efficient? Are they slightly more efficient? Are they equally efficient? Are trucks slightly more emission efficient, or trucks vastly more emission efficient? Now, one thing I'm going to try today that I'm new to this part of it, I'm going to see if I can send out a quiz or a poll if I could. So this will be the first one that I send out. Just give me your opinion on which one you think it is. So I'm going to launch that poll. Hopefully you'll be able to see. Oh, that's the wrong poll. Just one second. So here's a poll that I'll be sending out. Here we go. So it's exactly the questions that I just asked. I'll put it out there for about a minute. So once again, what we're trying to see is, I think most people have a preconceived idea of what that answer would be, which one would be vastly more efficient, which one would be slightly more efficient, or which one wouldn't be efficient at all. Most people already have that preconceived idea. One of the things that I want to be able to discuss today, and I hope we'll have a vigorous discussion as we get through it, is whether or not we'll actually see any kind of synergy or comparison where we can compare things apples to apples and not just generally, not just saying, hey, trains are more efficient or trucks are more efficient, but looking at the entire process. And that means from endpoint to endpoint, from beginning to end, what is it that we're looking at? I'm going to give this poll about 10 more seconds before I turn it off. I think most people have answered, still waiting for a couple more to put their answers in. Are trains vastly more efficient, slightly, equally? Just give me your result on that. All right, I'm going to end that poll. So right now, the result we get is that about 60% say trains are vastly more efficient. 40% are saying slightly. No one's saying equally. No one's saying slightly for trucks or vastly for trucks. So that's where we're standing at the moment. Now, I want to continue on. One thing that we need to do, though, is we need to be able to compare apples to apples. We need to be able to look at things specifically how it is they're actually, being performed. And one thing that I hadn't been able to see before is how we can actually compare these two mediums, the trains and trucks, apples to apples. So to do this, we're going to need some kind of common measurement between those two mediums. And that's going to add a little bit of difficulty because it's some mathematics, but I'm hoping you guys like mathematics, you enjoy them. So we'll actually get into that. I think my camera might have died on me. That's a possibility, but we'll continue to go on. All right. So to do this, I'm going to get into some mathematics. So here we go. It's not anything complex, so I don't think anybody is going to lose their mind over the difficulty. All right. So here's what we're going to do. What I found out, and maybe you already knew this, and I didn't know this to start. If you didn't know, train efficiency is measured in revenue ton miles, or RTM. So what is RTM? RTM is the capacity that can be moved on 1 unit of propellant or 1 unit of fuel to move 1 ton of freight. So we're talking about using 1 unit of fuel, whatever that would be, whether we're talking about, an electric powered vehicle, we're talking about diesel powered, what 1 unit of fuel will move that ton of freight? How far can it go? So I'm going to use this example. This comes directly from CSX as an example of how they measure a revenue ton mile. CSX totaled the amount of fuel for, in this case, diesel fuel for the year 2023. They used 196, or they moved 196 billion tons of revenue. So they're moving that much cargo. And they utilized 388 gallons of fuel, 388 million gallons of diesel fuel. So we divide 196 by 388 gallons of diesel fuel, and then we're able to determine that it comes out to be 506 revenue ton miles. So what they're saying is they can move 1 ton of freight 506 miles on 1 gallon of fuel. Now I think we'd all say that's pretty impressive. I think that's of course, based on scale. How much can you fit in a cargo, in a train cargo, in a train car? And we'll be able to balance this. Now let's see if we can use this to get an equal apples to apples comparison when it comes to putting these things on a truck. So when we go for trucks and we use revenue ton miles here, 19 tons of freight is about how much you can usually put on a truck. That's an average amount. And we want to move it a distance of 500 miles because we've already used that. We already used that number earlier. We just used it to say, this is how far we're moving, about 506 miles. So we're going to use 500 miles. So we take 19 revenue tons, move it 500 miles on 71 gallons of diesel fuel. So that's going to take us where we multiply 19 by 500 divided by 71. We get about 134 revenue ton miles. That's what we're looking at, 134 revenue ton miles. Now, if we just leave it at that, we could just wash our hands and say, well, thanks, Earl. You've given us the answer we need. We're all done. We don't need to know anymore. But I think we need to look a little bit farther into this, because this is where it comes down. The devil is really in the details. The devil does come down to being in the details in this. So we need to have that. Now that we have that basic apples to apples comparison using a revenue ton mile, let's take a look at the pieces of the railroad model that might be missed in that railroad model approach. So what we're going to go to, this slide gives you kind of a foreshadowing of what we'll be discussing. Here we have a truck receiving cargo, and we'll say that's 1 ton of cargo that's getting. In this case, it's probably dirt. They're probably just moving dirt from one place to another. It might be going to a construction site. But no matter what, we see 1 ton of cargo that needs to be moved to its complete destination. And that's one thing I want to remember in the discussion today. We're talking about endpoint to endpoint, to a complete destination. So to move that 1 ton of cargo, that complete destination, it has to go the entire cargo path from where it receives that ton to where it's dropped off at its final destination. And you see here a truck is receiving that ton of cargo, and there isn't really a train station in sight. And that'll be part of what we'll be discussing as we go through. Now here we see something similar. We'll be talking about train steps for cargo as well. Now this isn't a Photoshop picture at all. This is an actual picture. They're moving some gravel from one location to another. You've got the backhoe sitting right on top of the rail car, dropping it into an over-the-road truck. So that's for 1 ton of cargo to complete its total cargo path and actually get from endpoint to endpoint, its ultimate destination. The train needs some help. It can't. Very rarely do people have the train station come right up to their factory. Now, one of the factories I used to work at, we actually did have a train car that showed right up to the factory, but those are rare and far between. I've worked in about 4 different companies in my life, and only once have I had a train car show up right to our building. So we want to discuss the whole thing, the whole process, and we want to make sure that we can compare, once again, apples to apples. So this is a typical truck delivery. Path, the entire cargo path. Now this is of course basic. There might be a little bit added in here, but you have the factory where whatever it is you're getting, whatever thing you're producing, that 1 ton of cargo, I'll refer to that every time, that 1 ton of cargo is coming from the factory, and it goes through ITP. And what are ITPs? I'll use that as another piece of terminology today, internal transport processes. Now, those could be forklifts, excavators, loaders, anything that's taking that 1 ton out of the factory and putting it onto a truck, or putting it onto a rail car, or putting it into the place it needs to go to be transported. So then in this case, it gets on the truck, goes to right to its destination, and only needs one other set of ITPs in order to get that equipment off the truck into its final destination. Now, when we look at trains, trains are slightly different. We're going from a factory, we're using those ITPs, which once again could be a long list of things, and we'll go over that in just a second. It goes onto a truck, then goes to another set of ITPs in order to get onto the train. So you can see we've already added a truck and ITPs in this situation. We've already see where we're adding something to the entire cargo process. It gets on the train, then ITPs to get it off and into a truck, ITPs to its final destination. So there's a little bit added to this. Now, I'm not saying that's in all cases, but in many cases, that's what's added to it. How am I doing so far? Is everybody hearing me? I want to make sure I'm not losing anybody. Raise your hand if you're still hearing me, because I know my camera has definitely gone out, but I want to make sure you guys are still hearing me. Excellent. All right, great. Thank you. So we see we've got an added level of complexity when it comes to trains. Now, this isn't taking anything away, and don't anybody here who it says, hey, the emissions are much less on a train. I'm not here to push that down or deny that in any way. I just wanted to look at the full picture, the entire scope. Now, this is usually the more accurate train delivery schedule, is where it goes from factory to ITP to truck to ITP to a rail yard, a warehouse where it sits. Usually doesn't sit long. I think the average is usually, for the most part, about 48 days. I know that things are a little bit different right now, like with the strike that happened for that short period of time. I know things got backed up a little bit, but I would say, I mean, they're vastly efficient in being able to process those things out of their areas. Now, it goes from the rail yard to the ITP to the train to the ITP to the rail yard. So it's now coming out of the train onto ITPs, a truck, ITP destination. You see the amount of ITPs and trucks that are added as we get to an added level of complexity. And on average, and I'll probably get to that farther on average, the distance from the train to the final destination, and this is in a CARB document, and I'll be happy to provide any links that you need. Anybody who question anything like, oh, where'd you get that research from? I have this all in my notes. CARB shows that their estimation anywhere from 30 miles to 300 miles. So you got to remember, even after the train travels, it's 500 miles, which we were using as a reference. Now we've got to go another 300 miles, possibly, to get to its final destination. So that has to be added into the entire emissions and the entire emissions equation. So just for the last comparison, you see, this is, of course, a simplified truck. I mean, this probably wouldn't add any more than one more of these. Let's say truck to some type of warehouse, then to another truck, and then it goes over. It might be a little bit more complex, but it's not going to be a lot more complex than this. With train delivery, this is the minimum complexity, but most of the time it's going to run into this type of complexity where you see, compared to 2 ITPs, you've got 6 ITPs plus rail yards plus trucks added to the train. Now, I'm going to launch another poll right now. Give me a moment. I'll get that up for you. What we're going to be talking about now is we're shifting gears a little bit, and you might wonder why you're saying we're off on a different place. Why are we doing this, Earl? I don't get it. You'll see as we go through. I'm trying to make sure that we've got the same type of information. Once again, we're comparing apples to apples. And for those of you who might not be familiar with emissions and how they work, how they're calculated, the actual mass of them, the actual volume of them, this might help put it into your perspective. And I'm going to compare that to driving, a regular vehicle. So what do you think produces more GHG emissions? Do you think that a fork truck would produce more GHG emissions, or would you think a personal car would produce more GHG emissions? I'm going to give everybody a chance to answer that. I'm going to give you, I'll leave it up for about 60 seconds, maybe a little bit longer, in order to get an answer to find out exactly what you guys think. Now, the thing that I want you to get in your mind is how long do you think, and I probably should have brought this question up a little bit later. For GHG emissions production, we're basically comparing a fork truck to a passenger car. In fact, I'll stop sharing this one for a second, and I'll go back to the previous one that I should have shared first, which should have been, how often or how long do you think your vehicle will run? How long do you think your vehicle is actually running in a common day? How long would you say your vehicle is running in a common day? 15 to 45 minutes, 45 to 75 minutes, 75 to 105 minutes, or 105 plus minutes? What do you guys think? Just once again, this is average. Some people have to drive, an hour and a half to work. There's people around New York City that drive that way there and back. And I know when I used to live around DC, people live far away from DC. It'd take you an hour and 15 minutes easy to get back out to Fredericksburg or something like that. I'll leave this poll up for just a few more minutes. Now, at the same time, I want you to think about the other times that you're actually driving your car. It's not just driving back and forth to work. You've also got the fact that you were, maybe dropping the kids off at school, picking them up from soccer practice, going to, some type of volunteer event that you participate in, or just going out to the hockey game or going out to the football game tonight. See, on average, what would you say your amount of time? I think most people have answered it. Right now, we're looking at, most people are saying the average time that their car works or a car works during the day is 15 to 45 minutes. 43% are saying 45 to 75 minutes. So I'm going to close that poll out. Thank you for answering that. I appreciate it. Now, why my camera turned off that, I have no idea. Well, I'll give you the answer that comes from AAA, actually. This is a research that I got from AAA. The average amount of time that a vehicle runs, according to AAA, is around 60 minutes. That's give or take a few minutes. So about 43% of you are right there in that spot. That includes everything back and forth. That went across an entire span of age groups, and also went across an entire group of different types of drivers. Once again, I can give you a link to the actual research. It was done in 2023. But they're saying it's about 60 minutes that the average vehicle is running in a day. Now, I'm going to ask you another question. How long do you think, or how much do you think, and I'll put this poll up as well, how much do you think the average operating hours for a forklift are? So the average operating hours for a forklift each day. Once again, I got the same type of numbers here: 15 to 45 minutes, 45 to 75 minutes, 75 to 105 minutes, 105 to 135 minutes, or 135 plus. I'll let you guys answer that. And the reason I'm doing this, and the reason I did the other one in hours, the cars in hours, because once again, I'm trying to make sure that we compare apples to apples. Fork trucks and most ITPs, any of those internal processes, those devices are usually measured in hours or even in minutes, as opposed to how many miles. We usually are used to looking at our speedometer and going, or our odometer, and saying how many miles have we traveled. With a fork truck, that's different. We're looking at how much time has this engine been operating. And so you got to adjust your mind a little bit in that. Now, once again, the whole reason I'm going through this exercise is so you get a comparison between what you would know if you've never been a part of this before, what you would know as a passenger car versus a fork truck. Most people have never driven a fork truck. Most people have driven a passenger car. I'm going to end that poll right now. We've got about 17% saying 14 to 45 minutes, 17% saying 105 to 135 minutes, and then 67% saying 135 minutes plus. Now we'll go ahead and end that. Now, let me get back to our. So what I would tell you is I've found through the research that I've done that the amount of time that a fork truck actually runs per day, and some of you, it looks like you guys were dead on knowing this already. The amount of time that a fork truck runs per day is about 5.5 hours a day, or 330 minutes per day. So forklift, life, and you might call it a fork truck, forklift. Put in the comments which one you refer to it as, a fork truck or a forklift. I know, and there might be some places that just call it a lift. But a forklift lasts an average of about 5 years, and it runs about 10,000 hours before it's starting to die out. A really good one lasts for 20,000 hours. The average is about 10,000. One that's been really beat up is 5,000, and that's based on environment, whether it's inside or outside, how many shifts per day, 1, 2, or 3, is how much weight it's lifting, the maintenance, and the belt, oil changes, and filters. So when we look at it, so how much CO2 does a fork truck produce as opposed to a car? Now, I don't have anything ready in a poll for that. I'll just go right to what I have here. The EPA has an estimate for your typical passenger car. So a typical passenger car emits about 4.6 tons of carbon dioxide per year. 4.6 tons. Now, the emissions on fork trucks or forklifts, once again, however it is that you usually refer to them, they produce 7 tons of CO2 per year. Once again, they're running a little bit longer, and I would probably say that number is even a little bit higher, because as you saw from the previous information, the fork truck is running about 5 times more to 6 times more than the car is running during the day. Now, of course, fork trucks, we know that fork trucks, there's not as many of those on the road, or not on the road, in existence as there are passenger cars. But this still might fight your current informational systems about what emissions are and what is the highest producing emission, because we're always told that the highest producing emission segment is passenger cars or transportation, and more specifically passenger cars. Now, there's no doubt there's more passenger cars than fork trucks. There's probably 200 million passenger cars and somewhere around a couple of million fork trucks. But remember, the fork trucks aren't the only ITPs. I just used that as an example. There's also, and I've got a huge list here, fork trucks, excavators, bulldozers, loaders, cranes, backhoes, telehandlers, reach stackers, conveyor systems, dump trucks. I mean, the list just goes on of the other ITPs. And those are all part of the rail industry. And I would also include almost, they're not quite ITPs, but for the rail industry, our over-the-road truck is almost an ITP, because it's necessary to take the equipment or that 1 ton of cargo off a train and put it onto a truck. You need to get that last little definition or destination. You have to get to that last spot. You have to get from endpoint to endpoint, and the only way to do that is by putting it on a car or putting it on a truck, using the ITPs to get it from one to the next. Now, if we look at examples such as this, or graphs such as this, it can be a little bit misleading I would think, to the layperson, because they would look and they would say, all right, I can see just a little bit here. The rail is just a little tiny bit. But if you look over here, if we look for the entire cargo process of delivering that 1 ton of freight from endpoint to endpoint, that endpoint to endpoint is not synonymous with rail station to rail station. For instance, the rail station might only show 1% here, but it doesn't include the rails, all the steps that are required to complete. Let's say if we're talking about passengers, which we're talking about freight or freight movement, we need additional buses and taxis and trucks to get us from one place to the other. For freight, we need additional trucks and lorries. Now, with freight or for rail, we need additional forklifts, loaders, cranes. That's all additional stuff that needs to be added that we don't really talk about in our emissions measurement or our emissions number when it comes to trains. But this just shows how much more complex this measurement is. Now, if we're talking specifically moving just on the rail from endpoint to endpoint with the train from station to station. Yeah, everything I see, rail station, vastly more efficient from rail station to rail station. But we need to get to that endpoint. So I think this can be somewhat misleading. And another thing that we need to look at is the fact that we see scope 1 and scope 2 and scope 3 emissions becoming important in this day. Now, for those of you who are not familiar with these at all, scope 1 and scope 2 emissions, I'll give you just a brief definition, and I'll probably read most of this off, try to get it as accurate, but this is a very short explanation, so it's some generalities. So scope 1 and scope 2 emissions are relatively straightforward. Scope 1 emissions are greenhouse gases that an organization emits. So we're talking about right here. So company vehicles and company facilities. So we think about that for trucks. Think about that for trains. For trains, it's just station to station. That's their scope 1 emissions. Scope 2 emissions is purchased electricity. This is the emissions that are produced indirectly, that are using to power whatever things that they are using. Scope 2 are indirect emissions. Now, scope 3, this is where 90% of emissions are. And you can see it includes in here transportation and distribution. Now, for a train, those scope 3 emissions are going to include all those extra ITPs and all those trucks. Those are in the end to end from front to back. Now, once again, I'm saying that trains are very efficient when it comes to emissions. But if we look at the actual destination of that 1 ton of cargo from one place to another, making its complete trip, you've got to look at the other emissions that are included. And within transportation and distribution, you've got to include more ITPs and more over-the-road trucks, even in the train model. And this can get, and you can see how, and this particular pie graph comes from CARB. You can see that the numbers often shown for rail, we see that there might be more complexity than meets the eye. Once again, if we're talking about just destination to destination, rail station to rail station, this is probably very accurate. But in order to get a true picture, we need to look at the entire endpoint to endpoint cargo process. And you can see it in this as well. Now, this one right here is slightly different. This one comes from Statistica, and you can see they put rail at a different value. It's showing 1% right here, but they actually have it as 2%. I don't know why this is saying 1% at the moment. I must have changed that earlier, but it's actually 2%. Statistica estimates it at 2%. So, and all this comes back to us talking about now. As I close this up, we've just got a couple minutes, and then we'll open it up to questions. Now, as people speak about rail yards, they talk about, hey, if we electrify those rail yards, and they're actually very good candidates to electrify those rail yards as much as possible, because all those ITPs become electric, and everything's contained in that space. So to get rail yards electrified as opposed to passenger cars, or not over-the-road trucks, railroads are prime places to have those closed systems for electric ITPs. They can move and disperse that 1 ton of cargo across many states, many counties, if we're talking about the United States and Canada, which is what I know the best at the moment. In order to move those, if we electrify those places, it's excellent because it's a closed system, easy to charge all those things, which is a little more difficult to charge, the trucks. But, I think technology is advancing. But then we get into the whole other discussion about greenhouse gas emissions, because you see right now transportation is 28.3% of all greenhouse gas emissions in 2022. Once again, this one comes from CARB. And electricity is at 25.3%. Now, as electricity production increases with the current capabilities, that'll mean that we'll use more coal, oil, and natural gas to produce electricity. Now I understand that we're working with solar and we're working with windmills. They're not quite as efficient yet, and we don't have nuclear power, so we're not using that. Once again, like I said, this gets but as electricity production grows and we electrify more, it'll start to eclipse this number, and electricity will then be a larger number that we'll have to work with and find ways to bring the emissions down on that. But that's, once again, that's a discussion for a whole nother day. So in conclusion, we come back to the question from the beginning: are trains vastly more, trains slightly more, trains and trucks equally, trucks slightly, or trucks vastly? When I look at it from everything that I've looked at on this, I would agree with those of you who are saying that they're slightly more efficient. How much? Not quite sure. I wouldn't say they're vastly more efficient, as sometimes we can see if we just look at those initial numbers, 506 revenue ton miles compared to 134 revenue ton miles. We might say, that done, it's much better. But we have to add that whole endpoint from destination to destination. Now, I appreciate you guys giving me your time. This is, like I said, this is our first one. We've never done one of these before. I was happy to be able to participate in it and be able to do it. I want you to know that we want to have more informational conversations like this, about one a month, to address emissions related information, and I'd love feedback on what you guys would like to discuss. Now I'm gonna look at the webinar chat to see what we've got going on. Is there any consideration of fuel types in these studies? There was some consideration, like I'm not sure exactly what, if you're talking about like fork trucks, there's specific consideration when it comes to fork trucks and ITPs, whether you're using propane, whether you're using diesel gas, whether you're using just regular gasoline, blends of those types. In the fork truck studies, yes, there were. Once again, I'll be able to get that stuff out to you guys exactly where I got all this information from. One of the things that surprised me was that even using like propane was actually the one that it was propane was used more often, and I thought it was a less polluting, less greenhouse gases, but it actually produces almost twice what diesel would. So if we're talking specifically about that, then yeah, those studies were included. I think when I looked at CSX and a couple of other rail providers, they're experimenting with different types of fuels, but that wasn't so much part of the studies that I looked at least. I probably looked at about 20 different studies in order to get this information together. And once again, I'll give you a link to all those so you can take a look. Do you think there could be specific calculations that precisely determine which is more efficient for a company? For example, how far is the final destination for a train station? Yes, that's a great question. That's a great question, and that's actually something. If you look at Geotab actually, one of the research pieces that I looked at, they discuss specifically how they can make a difference and help you figure out which places would be more efficient, and that somebody in us as well, we work with companies like that to find out where would it be more efficient to be able to use electric, where would it be more efficient to use rail as opposed to truck. Once again, I think a lot of times people get confused and they see, oh, the train is more efficient, so they just automatically they're looking at emissions and they want to eliminate how many emissions they're putting out, how much they're putting in the atmosphere. So what they do is they just immediately they pick trains where, if you did a little research, you could see that a truck might be more efficient in a lot of situations. And once again, this is the reason I'm having these types of discussion, is so that we can help inform the public, so they know farther down where to look. Because a lot of times, if you're not involved in this type of study, and if you're not involved in this type of quantification, you just assume what people are telling you and leave it at that. Excellent question. So there are specific calculations, and I've got some of those in some of the studies where you would look. Now, once again, it becomes difficult at times, because you're going, okay, I want to travel, from the train. It's 300 miles from there, but is it a flat terrain? Like, are you dropping it off in Kansas City and heading west? Or is it hilly terrain? I'm dropping it off near Denver, and now I've got to go through the mountains. That can make a huge difference. Also, temperature can make a huge difference. So different calculations. It gets really specific for each company. Has anyone else got any questions? I'm hoping I'm seeing everybody's. Just wanted to make sure that worked. Let's see if I got any questions. I don't see anything here. I'm trying to monitor all the places that I can get questions from. All right. Yeah, please. Yeah, suggest titles for the webinar. I want to know what you guys want to talk about. Maybe there's something that you don't have time to research and in our everyday work. So here at Global MRV, we actually have equipment that we can use to test. We've tested trains before. We've worked on trains. We've worked on numerous trucks. We've worked on ocean-going vessels in order to determine what the emissions are. And once again, when it comes to those specific things, we need to make sure that we're actually testing like real driving emissions, or on a ship, real driving emissions on the ocean, on an ocean going vessel. We want to make sure that we're actually in place and not so much testing in a laboratory. And at Global MRV, that's what we do. But yeah, you suggest titles because I'd love to know what it is that you guys would want to talk about. I suggest ships next. I would love to hear about those emissions. Suggested title, Devils in the Details. All right. Devils in the details. All right. I'd love to look farther into that because I think right now, if you look, if we went back, and I'll go back real quick on our slides. You'll see that, you see like ships. Where are those at? Oh, I don't have it on that one. So ships and boats, right there at 3%. But once again, we've got to look from the fact that you got to get it from a truck or a train with an ITP out of a rail yard and get it onto that ship, onto that boat. Yes, yeah, so that'd be an excellent thing to look at, because I believe all the research that I looked at, because I was trying to focus on rail and trucks. I'm pretty sure when I saw ships and boats, it actually showed that as lower. So in this one right here from CARB shows ships at 3% as opposed to 2%. So I'll have to look at that because a couple of things I saw look like it would be slightly different than that. But once again, the devil's in the details. You're exactly right. Do you think the rail companies want to bury this information from the general public in an attempt to secure more contracts, or possibly as a way to limit the carbon taxes imposed upon? I mean, I suppose anything's possible, and I'm sure you always want to put your best foot forward. We do the same here at Global Hour. We want to put our best foot forward. Can we accomplish everything? No. Are we going to try to accomplish everything? Sure. And I'm sure that's the same thing with the trucking and train industries. They want to look as good as they possibly can. So I would tout that piece. Hey, we can move one. I mean, it was amazing when I found out that's the actual number that was calculated. We can move 1 ton of cargo 506 miles on only 1 tank of gas, or 1 gallon of diesel fuel. That was pretty amazing. I was pretty impressed by that, and I did not know that number until I did this research. Now, would I put that forward as that's my best foot? I'm going to put that foot forward, no doubt. Cruise ships would be interesting as well. And that's one of the interesting things I saw that was different as I looked through different pieces of information. There's a totally different calculation that you have to do when it's passenger versus freight. So once again, it's not always comparing apples to apples. Ships, so a passenger cruise or a pleasure cruise, you've got passengers on. That's a different calculation than freight, because you're not looking at revenue ton miles so much there. You're looking at passenger miles, and it's a whole different conversation. I wouldn't want to get too far into it because I know I haven't researched it enough to understand exactly how the emissions work for that. But I find that very interesting, just because once again, it's a whole different calculation. Has anyone else got any questions? Let me see. Or any other suggestions? I'm going to use these suggestions for sure. All right. I appreciate your time, everyone. I really appreciate your time. If you want to check out exactly what we do here at Global MRV, it's just globalmrv.com. So globalmrv.com. It's that simple. You can check out what it is that we've done in the past, what it is we plan to do in the future, the OEMs that we work with, the government organizations that we work with, and we'd love to work with you. But at the same time, the main reason I'm here is to start educating people and to learn from you guys. There's always things that I go through as I do them. People ask questions and go, "What about this? I didn't consider that part." And that's one of the things I found out in this research, or pieces that I just didn't consider. So I appreciate you guys taking the time. I hope to hear from you. I hope to see you again. Please send me an email. Tell me what I can do better. Tell me what I can change. Tell me how I can help you in your your quest to learn more about emissions. You can send it to me at earl.leatherland@globalmrv.com. And I'm going to put it in the chat right now. So it's earl.leatherland@globalmrv.com. Like I said, I always put my name in as William. My middle name is Earl. So now I know when people have talked to me before, because instead of calling me William, they call me Earl. They know me a little bit better. Well, I appreciate your time, guys. If there's no other questions, I think we'll close this down, and I hope to see you guys again in the next month. All right. Thank you.